sort of kind of in a small kind of way decipher. Number 12 on the back. All right. Explain why a random sample that shows that 36% of the U.S. population has no health insurance. Okay, so 36% doesn't have health insurance, does not provide strong evidence in favor of our alternative, even though it is far from the mean. So originally from above, we created normal curve that would have looked like this. .298, and then you can go up one further, 0.312, 0.256. So this is what should have been done on number 10, roughly. Okay, so they say they did the study that 36. They found that 36%. So that's somewhere way out here. Okay, so if we looked at our null, we would say this. If we looked at our original hypothesis, we would have said this. And then I think they found a standard error on this one, which they basically did 0.27 times 0.73 over 1,000. So that's where you get 0.014. And then they had told you that the original mean was 27% of 0.27. So we're looking at 12. It says, explain why a random sample that shows 36% of the U.S. population has no health insurance does not provide strong evidence in favor of our alternative, even though it is far from the mean. Well, our alternative is saying this. Okay? So we know that one, this is in the opposite direction of what we're testing. Okay, and we could have changed that in our original, but even with that, it is so far out there. It's so far out there that it wouldn't happen. Now, I'm not saying it would happen or wouldn't happen. And this, let's talk about this, just on a social basis. Yes, I realize there was Obamacare that went in. That was to try and persuade or hold people accountable to have health insurance, and to get low affordable health insurance. And if you talk to your parents will say the only thing that's happened with health insurance over the past 20 years is that it's increased dramatically over the years. So where you might find that 36% is in lower socioeconomic areas where you have a higher unemployment rate. That could have taken place. But if they had done a random sample of nationwide and they found this, it might have been purely coincidental that the random sample showed that. If you did it again, you probably wouldn't get those same results. You'd hopefully get something closer to the mean or less than the mean that's given. But it does happen, and that's kind of a really hard pill for people to swallow, to realize if you truly do a random sample of people or items or whatever, you cannot do a random sample in a specified region. If you took the poorest state and you went to the poorest state, you found the poorest city, and then that poorest city you found the poorest neighborhood, and then you're a random sample in that kind of situation, that's not a random sample. You're pigeonholing where you're trying to deal with that population. Now, unfortunately, too often the media will convey the sky is falling because that's exactly what they do. We've all we've all probably watched some sort of news report where a tornado came through some kind of town. Why do they find the person to speak who's missing a few teeth, and the few teeth that they still have in place are all rotted? And like if they're one sneeze away from losing another one, why do they find that person to interview? I don't know. Does it make the story better? Does it make it more believable? I don't know. But you know, it's just one of those things. So again, that's 22%. Or this result is in the opposite direction and provides evidence that the percent with no health insurance is greater than 27% and not less. So we just kind of, that's what our sample showed, and it could be coincidental, but it might not. What else did you see on the homework I could help you with?
For number 11, would it be 24% because it's closer to the average?
Let's see. Which result would produce stronger evidence in favor of our alternative? So less than 27%. A sample showed 22% had no health insurance, or a sample that showed 24% who had health insurance. Explain. 22%, this sample statistic is further from the mean from 27%, so that falls into our alternative. It gives us evidence of our hypothesis and not our null. Anything else? You feeling okay? Life's good for y'all? Congratulations to Chucky and her team. They're in the Elite Eight come Friday night. And for the first time since the semester started, I don't think there was a fight in the parking lot that I know of. So, yeah. It's because Ethan and his gang wasn't there to... I'm just kidding.
I didn't incite any gang violence.
Huh?
You
Tried to fight.
Oh.
Literally, kind of had a strap on it too.
What? Oh, what? Starts like stop recording.
At 7 minutes 20 seconds, there might be 7 minutes 20 seconds. YouTube's gonna disclaim this is not made for kids.
Yeah, it was kind of.
Hannah's a mob boss by the time.
It happens.
Let's just stop talking about Hannah.
All right. So all is good, my friends.
She has the underground drill.
All right. Let's do some notes. So I'm trying to get to 6-7. I'll eventually get there probably. Do what? Page 33. Yes, thank you. All right. Here we go. I am on page 33 of the notes. And we do have a standard deviation that we have to add. But I found out what Mr. Anderson had it be, so we won't get 0 when we do the...
Great. Do you have standard deviations in the homework as well?
I do.
Awesome.
Yes. All right. So 6-7, calculating the p-value on a one-tailed test. Again, realize there are 2-tailed tests, but we're going to stay with one tail. Recall that we informally defined p-value as the probability of obtaining a result at least as unlikely as the one we obtained by random chance. So if you're looking at the p-value, you're looking at the likelihood of obtaining a statistic at least as far from the null hypothesis mean as our sample. Okay, this assumes that the sample statistic is correct direction as our alternative. So if we have a less than and we found that we are the same distance but above, you're going the wrong direction. Okay, so the p-value is a shaded region on our normal distribution. So basically, if we had a shaded region, that's just not just a thick line, we have a p-value that's in that region, okay? So we have to add a standard deviation to this example. So this example says, assume that the average price for a movie ticket was known to be $11 in the year 2010. Boy, those were the days, $11 movie tickets. Has the average price of the ticket risen since then? Assume our plan is to survey 600 random movie theaters. Okay, and then I'm going to tell you, so we know that our average on this example is going to be 11. And then we need to add a standard deviation of $1. Okay, so this is, we need to add this to the example because it was missing. Supposedly it's fixed for next year. Next year they get so much better than you guys. You know, just say this, but this. All right. So the null hypothesis. So H naught we're going to say, and we're away from writing our long sentences. This is our null, and our alternative is that our average is greater than. So we're going to the right. Okay, so draw this null sampling hypothesis. So we have to find our standard error. And our standard error will be that we have a mean of 11 and we sampled 600 people. So will somebody tell me what 11 divided by square root of 600 would be?
Hold on,
Yeah, but we had 600. Oh, yeah, standard deviation, 1. Yeah. I had a 1 in there. It's just there happened to be 2 of them sitting next to each other. All right, so what's 1 divided by square root 600?
Square root of 600 is 24.49.
1 divided by that?
0.041.
Okay, so this is our new standard error. This becomes our standard deviation. We use that because we had 600 people, so we're trying to figure out how close to the mean we would be. If we draw our normal distribution with what we know, we would have our mean of 11, and then let's just round this to, let's make this 0.04. Ooh, something's going on in the hallway. All units in West.
Well, yeah, I mean, people screamed it, like, everyone needed to know, like, well, not needed to know, it's like.
All right, here we go. So that's basically what our null hypothesis sampling distribution would be. Let's assume that the sample produced an average of $11.45. Okay, so we produce $11.45. So let's assume that we had a sample, some random sample that produced $11.45. Okay, where's 11.45 based on our normal curve? To the right or to the left? Yeah, 11.45 is way out that way, right? So let's see. Okay, use Normalcdf to calculate the p-value. Okay, so Normalcdf is what we're going to use, and I'm going to jump into on that. Let the calculator warm up. Take a swig of coffee. Is my calculator not coming up? All right. So let's see. Gio made it. Welcome back, my friend.
Welcome back.
Megan, did you make it?
I was here.
Megan's not here, right?
Yesterday. Yeah. I'm sorry he cares about me coming back and not you.
I care about all of you. All of you make me a better person.
You make us better people.
Right.
All right. So second bar is Normalcdf. All right. So Our lower limit on the normal CDF would be the 11. The reason that's our lower is because our null or our hypothesis, we wanted greater. So then our upper, we just need to make greater. And we can go with the 1145.
Well, but isn't that going to give us an answer between the two?
Yeah, let's not do that. Let's go with like 12, because 12 would be way out there. 1245 sounds good.
1245?
I don't know, I'm just going, that's much farther to the right, many standard deviations away. What did we say our mean was? 11. And I'm on the wrong screen to see what we came up with.
The standard error?
Yeah.
0.04.
So let's just go 0.04. Keep it as money values. All right, so we wind up with, I do that right? Let's see, okay. 0.499995, so roughly 0.5. Okay, so our p-value, let's just round that to 0.5. So p-value. We found that from the normal CDF. All right, next page. Let's assume that researchers set the alpha to 0.05. Okay, so they're now changing the alpha to 0.05. Okay, which means they wanted to say, hey, we want to be 5% confident that our information is correct. Okay, what would this do? What would our research decision be? Okay, so 0.05 is here. Our p-value we got was this. So this is like that one question. It was on our homework, or similar to our homework question we had. It was like on assignment 6.5, which is 103, where we said we assume that the p-value is 0.042 and set alpha to 0.08. Well, this one is 0.05, where our p-value is 0.5. Okay, so that created some discrepancy. I mean, we're talking about 10 times the difference. So we should definitely be able to find evidence to go ahead and reject our null, meaning we found evidence for our hypothesis that movie tickets are indeed higher than $11. Okay, the price went up. In summary, we calculate the p-value as percentage of normal distribution that is farther away from the null hypothesis than our mean of our sample statistic, which is fine. And then there's a caution that we have here. Make sure that the statistic in the same direction as the alternative. It is in this case. Okay. For example, our alternative hypothesis in the movie problem was greater than $11. This in theory is we were trying to find strong evidence in that direction to the right. What if our sample produced an average of 1065? We certainly can use a sample statistic of 1065 as evidence that a movie ticket prices have gone above 11. In this case, the sample contradicts our alternative, and we would automatically fail to reject the null hypothesis. Okay, caution number 2, it's bad. Yes, okay, I don't know why. To use normal distribution to model data that is not normally distributed, use the central limit theorem as a guide to check for normalcy. This means for means in the population is known as, is our sample greater than or equal to 30? So we're bringing that 30 back in. And if we have proportions, we use the n times p and n minus p, where they are both greater than or equal to 10. So that's kind of good. And then it goes in and it says, make sure you have the standard error, know that, and the standard of the mean and the standard error of the population. And that is as far as I should go today. Hey, a lot of homework tonight? Okay, yeah.
I have a haircut today. I can't.
You have a haircut today, she can't?
Yeah.
Gio, you have...
So long ago.
Gio, I will tell you, you have great hair. Your haircut takes much longer than mine. Because I am approaching a haircut, a singular haircut. So let's have you just do page 107, 1 through 3. I will tell you on number 2, make sure you have a standard deviation. Add this standard deviation of 4. And on problem number 3, make sure you have a standard deviation of 40. Okay, so add those to the mix. We will have a quiz sometime next week. Can't tell you the exact date, but Friday next week is not a test. We're going to have some fun.
Sure, what's the standard deviation for number 1?
Is it 4 rings? It's 4 rings.
I can ask a coin actually. Heads more than 50% of the time when it's flipped.
What is the name of the rings?
0.4.
Yeah, let's have a standard deviation on number 1. What do you want? Let's make it up.
Okay, well, I was wondering if 0.4 says we obtained 50.4%.
Hang on, let's see.
Average is 50%.
Okay, this makes me ready.
What's up?
What's the name of this volcano?
I'll come in during access to take my quiz class.
Okay.
1 to 6:30.
Standard deviation on this one will make is 0.5.
Okay, thank you.
Yep. Cool. All right. Let's save.